Since 1968, Kaplan Early Learning Company has championed play as a transformative learning experience. A leading international provider in the field of early care and education, the organization provides quality early childhood resources to federally supported programs, as well as school systems and child care centers worldwide to inspire a lifelong passion for learning in all of us. Kaplan Early Learning Company is the exclusive distributor of Connect for Learning, an interdisciplinary pre-K curriculum researched and written by today's keynote speakers, Drs. Julie Sarama and Douglas Clements. Please enjoy the following brief video introduction to our sponsor of the upcoming keynote, Kaplan Early Learning Company.
We're for play and all of its possibilities. How it pulls us together and sets us free to explore. We believe that learning and fun are lifetime companions, and that the earlier they meet, the more inseparable they become. We're for bond building between student and teacher, child and parent, friend and friend, and all of the combinations therein. We are defenders of the imagination and the archenemy of dull, architects of learning environments, creators of learning goods and good, keepers of the learning flame. We live for open minds and the opportunity to shape them. Let's encourage the eager. Let's inspire the inspirers. Let's get to work on play.
Dr. Doug Clements and Dr. Julie Sarama are joining us from the University of Denver. Dr. Clements is a major scholar in the field of early childhood mathematics and STEM education. Dr. Sarama conducts research on young children's development of mathematical concepts, implementation and scale-up of educational reform, professional development, and implementation effects of software environments in mathematics classrooms. Their presentation will focus on children's learning trajectories and the surprising capability of young children to learn math. We are beyond thrilled to have them join us and would be remiss in not thanking and acknowledging them for the profound impact their work and scholarship has had in influencing the efforts of the Early Math Project. Please welcome Dr. Doug Clements and Dr. Julie Sarama.
Hi, Doug Clements here. Happy to be with you. I'm honored to be a part of this event. Unfortunately, Julie Sarama, a more fun part of our pair, horrible migraine all last night, so won't be with us today. She apologizes. Let's talk about what counts in teaching and learning early math, and especially an emphasis on learning trajectories for young children. Children have amazing potential to learn early mathematics. It can be broad, it can be complex, and it can be sophisticated as long as it's done in a developmentally.
Abby, how much is 9 take away 4?
Interviewing Abby.
Five.
Good. How do you know?
I know that 4 and 4 is 8. So when I think of 9, I know that there's one more. So if I take away 4, it's like take away 4 from 8. So if there's one more still hanging down, I'll put that on as 5.
Good.
What's remarkable about this, right? There's several things that are remarkable about Abby's behavior. She's 4 years old and she's doing arithmetic. That might be enough. She's strategic. She doesn't know what 9 take away 4 is, but she realizes I can think about 4 plus 4 is 8, but then I got 9. So there's one more. So does she do this concretely or does she do it abstractly? It's kind of a combination of the two, right? Because she puts one over here, but there's no objects. Mentally, there are for her. She puts one over there. She drops 4 off the table. You can almost hear it plop on the floor. And then she brings back that 1 and says that the answer is 5. Remarkable thinking of a 4-year-old. We need to keep that kind of potential realized for all children. How? We believe Learning Trajectories makes a substantive contribution to just that. So what I'm going to talk about today are what are learning trajectories, give you a couple examples to concretize it, then talk about why are they so effective, how do you use them well, and then we'll return that video emphasized kids play. What is the relationship between play and early mathematics? Okay, here we go. Learning trajectories have 3 parts. There's a goal we want the child to reach, so consider it as if you're walking to a garden gate. And then there's a developmental progression, or kind of like the steps to the garden gate, the levels of thinking through which kids pass on their way to reaching that goal. And then finally, there's instructional activities, the environment, the interactions, intentional activities, everyday activities, fine-tuned for each step or level of thinking to help kids develop the following level of thinking. Why important? Because in the present day, sure, we have research on mathematics goals that help kids, that helped us develop standards. We know a little bit about levels of thinking. That's really helped us build assessments, and we know about good activities for kids, and that's helped us build curriculum and teaching. But people, only a scientific approach to learning trajectories weaves those 3 research corpus together so that standards, curriculum, teaching, and assessments all come from a common research base. So let's take an example. I'm going to deal with a quantification method that isn't counting, but is very important and often ignored. So I want you to just think to yourself, when I show you the next picture as quickly as you can, think to yourself, what do you see? Kind of put it in words for yourself. Ready? Most of you probably said something like 3 trees. So this is going to be our first example. The topic is recognition of number and subitizing, and I'll say more about that in a minute. But first, recognition of number is not recognition of numerals. That's a valuable skill, but it's a language arts skill. So we want kids to read a 5, but that's not what I'm talking about today. You probably didn't count the 3 trees. When I showed the picture, you probably just saw 3 trees. That's recognition of number. And when it gets fast, like this for kids, it's subitizing. Comes from the Latin word for suddenly. So kids recognize and then recognize quickly the number in a group without counting. It follows a developmental progression. Let me first tell you about the broad kind of levels. We start with what's called the approximate number system. More on that in just a second. Then we move to perceptual subitizing, and there's levels of that. And then there's a big qualitative shift to conceptual subitizing, and then there's levels of that. These levels start at birth, I'm not kidding, and go up to 2nd or 3rd grade. So when does it begin? What am I talking about, birth? Is it that kids know numbers when in the first months of life? Well, no, but they're sensitive to numbers. There's a lot of research paradigms. I'm going to show you a novel numerical change detection paradigm, okay? It'll be more clear when I show you this little infant who's sitting in a high chair, and they are going to show this in the middle here so that the child starts centering their attention there. And then they're going to show pictures of numbers, 1 on each side. The dot size changes, the arrangement changes, the amount of area of that rectangle changes, but only one side changes in number. Notice the child, right? The child is spending more time looking at the 1 on our left that's changing in number. And indeed, the child still thinks maybe there's something on the other side that's interesting too. So take a look. Look, did you see that? Looked and dismissed that as not as interesting. In fact, he thinks it's really interesting and really fun. He looks one more time at the other side, just checks it out quickly. But nope. That is something over there. In the first months of life, kids are sensitive to changes in number, even though there's lots of variables changing. So you saw him check on the other side, but not think it's as interesting. So that's early sensitivity to number. Then children learn to recognize number, not necessarily quickly, that's recognition of number, and then they get to perceptual subitizing. Let's do some. When I put this up there in the go away, I'm sure you said 4. I saw it, right? Yep, that's perceptual subitizing. It's really inborn, but not the ability to know the number. That gets to be developed, of course, right? But there's 2 types of subitizing. So perceptual goes through levels, and then conceptual. What's conceptual? There you go. I hope I showed that far without surprising you too much. You probably saw 8. Nobody can see 8. What we can see perceptually is the 5 and the 3, and then we put that together to make 8. Conceptual subitizing. So learning trajectories are like a garden path, like I said before. And let's go through some more fine-tuned levels to explain how recognition, sensitivity number, which is here, that's foundations, and then recognition of number. At first, kids can recognize number. The 2 triangles have to be there for the kid to know, or the kids can see 2 doggies. Then they can make a copy of bonk, bonk, bonk. If they see those 3, they can make something that looks kind of like a face maybe to them or the like. And then,
how old you are?
Here's a child.
Okay.
Who could do that.
Can you show me a different way with your fingers?
Please.
Uh-huh.
Please.
Uh-huh.
Please.
Yeah.
Please.
Yeah. Okay, thank you.
Yeah, thank you. He knows 3. It's easy to teach a kid maybe to make one arrangement when you say, how old are you? Which he just turned 3. But to be able to do it in different ways when asked, this kid has it down, right? So he can make small collections for sure. Perceptual subitizing, did you notice those triangles come up and disappear very quickly? Then that's a level. Then perceptual to 5, like this. Then it moves to conceptual, where kids might be able to see 5, but 5 done in different arrangements like that, right? And then it moves up to conceptual to 10. And honestly, I'm going to stop there, but it keeps going up. So in the primary grades, kids really build strong concepts if they can get up to 20. That covers all their basic facts, really, in different ways, and their basic arithmetic combinations if they can see these different parts and wholes, right? And then 2nd or 3rd grade, we can show kids 3 10s and 4 1s, 2 10s and 5 1s, and ask them how many in all. After showing that for just 1 second, boy, if ever there was an antidote to kids doing rote addition algorithms, this would be it. This is conceptual based arithmetic, right? Now that's the second part, the developmental sequence. What are the instructional activities? How do we design them? What characteristics do they need to have? Well, they have to be connected to each level of the developmental progression. It's not just one set of activities, different activities for different levels of thinking. That's what makes it so precise and effective. We'll get back to that later. It should be designed to promote thinking at that level, and it should include everything, the settings, learning centers, how you set up the classroom, and specific intentional instructional tasks and specific teaching strategies. These are all active. We're not talking worksheets here, but conceptual representations and active kind of engagement. Everyday activities, good. Group activities, specific small group, whole group, and computer activities, all are effective in developing this recognition of number and subitizing. So, examples. For the teachers of the youngest kids, but all the way up to kindergarten, and for sure, maybe beyond, a simple but continuous intervention makes a huge difference, and it is so simple. Use small numbers in everyday talk. it makes a big difference if a teacher doesn't say, clean up those last blocks, but says, I see 3 blocks. Can you help me clean those up? There's still you see those 2 bottles? I'm worried those are going to spill. Could you move those to the side? In a study by Hunula, she found in Europe that if even teachers of 3-year-olds found it a little hard to make sure they use small numbers every day, but after 2 weeks, they just did it naturally. It didn't take any time out of their day, and it closed the gap between kids who came from low resource communities and higher resource communities in their ability to recognize number and subitizing, because it not only gives them hundreds of experiences doing this in school, but on the way home, they don't see bikes anymore. They see 2 bikes. They don't see red cars. They see 3 red cars. It opens a mathematical lens for kids. So let me give you some more examples of intentional activities. That was intentional too, but every day. So some organized activities that come from our Connect for Learning curriculum. We thank Nell Duke did the literacy, ML Hemmeter did the social-emotional part of the curriculum, Kim Brenneman, the science, and Julie and I did the mathematics. So one of our favorite activities for that, we just call Subitize. And it really is a very simple activity. Kids find it a lot of fun. And that is, you just have a number of objects hidden under a plate or on, under a cloth or something. You show it for just 1 to 2 seconds and you cover it again. And then kids think, pair, share, and they talk to each other and name the amount. And there's so many variations of this kind of thing. We also use literature, right? So Don Cruz's 10 Black Dots is great for this. If you know the book, I'll just show you 1 page of it. 1 dot can make a sun, and then 2 dots do this, and 3 dots do this, etc. It's great. And then we always read the book as quality literature first. But then you can go back to the book and do activities that are subitizing activities, such as this teacher shows us here.
Ready? For 2 seconds. Set, go. Show your fingers, just with your fingers. For 2 seconds.
Okay.
Ready?
So that's the kind of thing she does. And then subitizing can take off. So what she did after 10 Black Dots is give kids these kind of blocks or little circles that stick on, or you can do stampers or something like that. And they create pictures and they label them, of course, with the number that they use to do eyes on a crocodile and the like. And then when kids are ready in the C4L curriculum, we move them pretty quick to conceptual subitizing, advancing that by making sure that the arrangement suggests different ways to look at the number, right? But we want kids to be creative, so we don't tell the kids how to see it. We don't use 2 colors, for example. The reason there's just 1 color is because kids seeing the one on the left. A lot of kids will say, I saw 4 on the top and 1 on the bottom. But some kids will say, I saw 2 and 2 and 1. Some kids will say, I saw 3 along here and then 2 on the other side. Great, because then they see these combinations that make these numbers. They are learning arithmetic facts when they're 3 and 4 by a conceptual, visual, fun means, right? Example number 2 for the learning trajectory, and feel free to post questions, by the way. I'm trying to monitor that window. I will stop, even though I'm kind of on a roll here. I love to stop and answer somebody's questions. So if I'm going too fast, if you wanted to hear a little bit more about something else, feel free to put it in the viewer interaction window there. I can't, counting learning trajectory goes from like 1 or 2 years of age all the way up to 3rd grade 2. I can't, in the time given today, do an exhaustive job of it, but I did want to show you relationships between the learning trajectories in a second at the end when we get to the instructional activities. Let's look at a couple levels, right? First of all, the goal is accurate, fluent counting. Verbal counting, sure. Object counting, and counting strategies, okay? Most people do verbal counting. They call it rote counting. We don't, because at the very beginning, even verbal counting is filled with relationships for kids. Object counting, many people do, but they don't always do all levels. And some kids get lost there. I'll make a point of that in a sec. And then counting strategies is where this counting becomes arithmetical and problem-solving oriented. It deals with comparison of quantities and adding and subtracting quantities. Okay, let's take a look at a couple levels. First of all, verbal counting. So many kindergarten curricula start out with kids verbally counting to 5. Really? If kids are in any kind of a good preschool and that kind of stuff, they can count so much higher. These kids are not, one of them is not even 3 yet. And let's take a look at their verbal counting.
3, 4, 5, 6, 7, 8, 9, 10.
Math, fun at any age. Then what happens next? What's the next developmental level?
Would you count these for me? How many chips are there all together? Thank you.
So, what's different? What's new there? What's the advance? Beautiful one-to-one correspondence, right? Keep a one-to-one correspondence is a tough thing for kids to develop over years, but at least up to 5, and at least in a horizontal line, this child's got it down. But the next level, what she's going to learn next is something that a lot of teachers don't emphasize. But let's look at the next video and think to yourself, what's different between when this child was asked, so how many did you count? And the next girl. Here we go.
What are those? I'll bet you know. I bought these bananas. Can you count? I do too. I saw you eating them the other day when I was here. Could you count those bananas and tell me how many there are?
1, 2, 3, 4, 5.
How many?
5.
5.
Okay, so the girl before was a good corresponder. See those earlier levels, kids say numbers, then they chant, element P kind of chanting. Then the reciter can say the numbers like the 2 little kids that we saw in the fireplace, and then the corresponder. But do you remember what she did when she was asked how many, right? Let's go back there.
Thank you.
Oops, I didn't go back far enough. What she did, right, is count 1, 2, 3, 4, 5. How many? 1, 2, 3, 4, 5. She didn't seem to understand what this was.
I bought these bananas. Can you count? I do too. I saw you eating them the other day when I was here. Could you count those bananas and tell me how many there are?
1, 2, 3, 4, 5.
How many?
5.
5.
That's just obvious to her. And it's so obvious to so many adults that they often don't ask kids how many at the end. Because the first girl thinks the answer to how many is to recount the 5 objects. The second girl knows the last number word tells how many. That's the level of counter small numbers, the cardinal principle. Cardinal just means how manyness, right? The cardinal principle or cardinal rule is the last number word tells how many in the set. And it's easy to think, well, isn't that obvious? I'll just tell the kids, say the last number again. But when you're counting, it's an ordinal process. In other words, I got to keep my number words in order, 1, 2, 3, 4, 5. I got to keep my objects in order, so I touch each one once and only once and keep correspondence. But then at the end, this one tells how many. I have to make what Karen Fusion calls the count to cardinal transition. Gelman found years ago that Kids with a lot of experience counting at age 2.5 could do this. Can you count these? Sure. 1, 2, 3, 4, 5. Oh, good. Can you count them again and make this one? Sure. 1, 2, 3, 4, 5. How many are there? 5. They knew the cardinal rule. They knew it didn't matter what one they started with. The set would have a cardinal value of 5. That's incredible. And what it takes? Experience, right? Experience at the level. It takes teachers who are aware of these levels. So if they see the kid go 1, 2, 3, 4, 5, and they ask how many, and the kid goes 1, 2, 3, 4, 5, I need some instructional activities, some interactions with that child to move her from the corresponder level to the counter small numbers level. What kind of thing? I'll tell you in 1 minute. But let me first say, this new research came out. Well, it's 3 years old now, but I just read it recently. What do you think about cardinality? What do you think about kids knowing last number word tells how many? Is it okay if they learn that in first grade? Is it okay if they learn that in kindergarten? Shockingly, no. They found that's too late to succeed in primary school. Even entry to kindergarten is not soon enough. They need it during preschool. 3- and 4-year-olds can learn this with the right experience. And that makes a huge difference to their success in mathematics. And mathematics is one of the best predictors of school success later on, right up there. How kids do in mathematics in early childhood predicts graduation from high school and entry to college. That's the kind of power that the importance of early mathematics has. Okay, so let's go to the instructional activities. And what if we did have the girl who didn't understand that the last word tells how many? I want to give you an example of an activity from C4L called How Many in My Hand. And it's going to illustrate, number one, a powerful, simple, but powerful approach to teaching that without didactically telling kids the last word tells how many. Very ineffective. And it also will show you how carefully designed sequences of subitizing can help counting. And then counting can help subitizing. These things interact. Let's take a look. I'm going to have to fake it up on a screen. But what we really do in this kind of activity, of course, is a teacher will come in and say, the traditional teacher will say, put 4 blocks out and say, count these with me. And then the teacher will point and tell all the kids to count with her 1, 2, 3, 4. And that's the end. Or she'll put a different number out and they'll go 1, 2, 3 or 1, 2, 3, 4, 5. That's the traditional way. What do C4L teachers do? This. They would walk in and say, okay, you know what? I saw those inch cubes we like to play with. And this morning I just thought to myself, I wonder how many I can hold in one hand. So I got a bunch of the inch cubes and I have them in my hand behind my back. So will you count them with me? And let's see how many I have in my hand. Pulls her hand out, but still hiding the inch cubes, right, from sight. And then, and I'll just do it on the screen, fake it up here. She pulls one out and the kids all say 1. She pulls another one out. The kids say 2. Another one, 3. And the last one, 4. Showing empty hands, says, that's all I have. So how many is it? She gestures around them and says 4. 4 is what I could hold. Listen, you have smaller hands than me, so I don't think you'd be able to hold 4, but I put them out on the table. So during free time today, why don't you see how many you can hold in one hand? And that's the end. I told you it's a simple activity, but it's got some characteristics, research-based, learning trajectory-based characteristics that are key to helping kids understand cardinality. What are they? I hope you noticed. Let's do that again, right? Let's see the first way. When we counted this first way, the traditional way that most teachers do it, right? We counted 1. How many did we see? How many are we looking at? 4. Then we said 2. Then we said 3. Then we said 4. There's no connection. And do you notice when I did it the traditional way, I didn't ask how many when we finished counting. I just said good, as if the correspondence was all that mattered. No, that's missing that important principle, right? So how about the C4L way? Well, first of all, there's a little bit of curiosity we try to engender. I put as many behind my back as I could hold in one hand. Let's count to find out how many. So number 1, I'm asking kids to be curious. I wonder how many. I've asked a quantitative question. People, we so often count just to count. But the important thing about counting is it solves a problem. Simple problem. How many can I hold in my hand? We want to know how many. That's what we did. We posed the question that counting is going to answer. Then think if you can subitize. Because in C4L, we developed the subitization before we developed this level of counting that involves the counter small number, the cardinality rule. So when we start counting, I take 1 out and kids all say 1. Now, if they can subitize 1 block, yeah, I know 1. That is 1. And then when we count 2, I see 2. I get it. Yeah, when we see 3 blocks, then we say 3 because 3 tells how many blocks I see. And even if a kid can't subitize 4, when he sees that block, oh, so that's what 4 looks like. Okay. And then, right, the teacher gestures around him to make sure that, again, at the end, we know that 4 then is the answer. That's the set. That's the number that's in the set. Huge difference in these. These are very simple activities, right? Not all we do, but a huge difference in the use of the learning trajectories, of the recognition of kids' thinking in designing what you do with kids. Then, just as an example of another activity, very important to play board games. Research shows the first board game should not be the kind of Candyland back and forth. No. It's much more effective if they have a straight path. So in our game, Get Goldilocks Home, they roll a die and they move and they're trying to get Goldilocks to their home. That develops not only do they see the die and then they could subitize or count the 3 that's shown. Then they have to produce a set of 3 jumps to move their things. So they're at the next level, actually, produce their small numbers, right? And they're seeing the relationship between they're on 3, they roll a 3, they do 3 jumps, they're on 6. 6 is after 3, right? And all those kind of numerical relationships that you get. Research is quite clear that these kind of well-designed board games are essential component of instruction to get kids to these levels. Now, all I did is show you subitizing and counting. And counting only a little bit. I didn't go up into counting the double-digit numbers and everything else, which is an important counting skill. But I want to remind you, of course, that this is just one little talk. And so there is a huge amount of topics that are important to young children to learn. And we lay out not only the topics, but the learning trajectories, meaning we have resources to teach teachers and others about parents, childcare, everybody, about the developmental progression of these topics and instructional activities along each developmental level. It's at a website called learningtrajectories.org, and I show a picture of one. Here's Learning Trajectories to give you a notion of look at the number of topics there are: counting, subitizing, comparing number, adding and subtracting. Starts at age 2.5 to 3 and works up. Composing numbers. That would be like the conceptual subitizing, right? When you can compose them and take them in very quickly. Fractions, patterning and algebraic thinking. And then geometry and spatial thinking, spatial visualization, orientation, shapes, composing 3D shapes, like block building, right? And then measurement of length and area and even volume. Good experiences in early childhood do all these. Classification and data analysis, very important for all of STEM and literacy and social emotional development. So some of these things are cross-cutting, to be sure. Let's move on. Why are learning trajectories so very effective? And we know this. We're conducting a study funded by the Institute of Educational Sciences, the research end of the Department of Education for the U.S. And we have been comparing learning trajectories to very similar activities, but not along the developmental progression. And I can send anybody who's interested or has insomnia copies of our research articles. Love to hear from you. douglas.clements@du.edu. Glad to send it to you. Learning trajectories like underlie C4L are more effective than other approaches to teaching. We even found, for example, for kindergartners, first learning arithmetic, that if you teach the skill you want them to have, the target skill, for 20 sessions, 10 minutes each, and then you teach the developmental levels that start where the child is and then works up to that target. Kids who learn that target skill, every single session got way more minutes on the target skill, are outperformed by kids that come up through the levels. And all these levels, problems or tasks that go from all these levels in between, they do better on all those. And the target level, even though the kids in what we call the skip levels or teach to target group got more instruction at that level. No, but they didn't develop the conceptual ideas that research shows is clearly involved in bringing kids up to a full understanding of the target level. So now let's go back. Why are they effective? Because they're the mathematics of children. Learning trajectories are math their way, the way children think about math or science or engineering, and the way they learn about mathematics. It brings forth the natural creativity, intelligence of children, as you saw in several of the videos I showed. Importantly, it's developmentally appropriate and it's asset-based by its very nature. In other words, we are always starting where the kid is and with the strengths the kids have. And they have strengths, like I showed you before, from birth. So some kids have had access to a lot of good charging stations in their lives, in their homes, communities, schools. Some kids, in different geographic positions in the United States, not so many charging stations. But when we do a good, solid curriculum with them in ages 3 and 4, and then continue into kindergarten, they catch up. They just haven't had the opportunities to learn. So we base it on the kids' strengths and knowledge and build from there, developmentally appropriate, because it's exactly the way kids develop these things naturally. And it's based on where the kid is now, a point to which I'll return in a second. Learning trajectories open teachers' eyes to the potential of kids to do interesting and joyous mathematics. And STEM, the science, technology, engineering too. Literacy too. We use learning trajectories for all the topics in C4L. They're very well developed in mathematics, but there's a start to these kind of learning trajectories in all domains. So teachers, when we teach teachers this, for instance, in one huge study we did in Buffalo and Boston, we work with the teachers for 2 years, and then we work with the kids into kindergarten and first grade. And then when the whole study was over, 2 years of professional development and everything, and we said goodbye, we waited 2 years and we went back, because the research would show some teachers will do a lot of it, some teachers will do some teachers just move on to something else past these things. We thought, how much is it going to fade out? Here's what we found 2 years later. No free lunches anymore, no PD, no coaching. Teachers taught it with higher quality and fidelity than they did when we were there. A little embarrassing, they didn't need us anymore. Because once you understand kids' thinking, once you see the joy in kids' eyes, once you understand math as a creative and interesting and natural activity on the part of kids, you never teach math the same way again. So the first step in good teaching, we know, is then understanding what children know already and can do already and building on it. That's why another reason that learning trajectories are so effective is because of formative assessment is effective. I was honored to be on President Bush's National Math Advisory Panel. We produced the report, Foundations for Success, and I was also on the Early Childhood National Research Council panel on early childhood. Incidentally, if you could see that small in the screen, the subtitle of mathematics in early childhood is Learning Paths Towards Excellence and Equity. Yeah, the entire report is about learning trajectories for excellence and equity because it closes the gap for kids who haven't had charging stations, who haven't had equal opportunities to learn when teachers do it well. How do you do it well? And why are learning trajectories particularly good for formative assessment? Because my point was both of these reports talked about formative assessment and how it is one of the most underused but effective teaching techniques. This is why. Think about formative assessment. It asks three key questions. Where are you trying to go? Where are you now? And how can you get there? Think about the three parts of the learning trajectory. Where are you trying to go is the learning trajectory goal. Where are you now is the learning trajectory's developmental level. Where are kids now and what are the next levels? All educators say we have to start where the child is, but if you don't know the developmental progression, how do you conceptualize where they are? And how do you know where to go next? Learning trajectories provides that. And then how do you get there? Well, that's learning trajectories help setting up the environment, activities, and teaching strategies to be an effective teacher. So coming to my last point, what about play? There is a lot of unfortunate, what Julie and I call false dichotomies out there when early childhood people argue about the role of play. So sometimes we've gone and shown some of our activities, our learningtrajectories.org website or whatever, our curricula to people, and you'll have an occasional person who will say, I don't believe in curriculum. I believe that kids should learn through play. Well, they're right. What's unfortunate is if they think that play is adverse to academics and academics adverse to play. No. NAUYC, the National Association for the Education of Young Children, for decades now, has said it's not either or, it's both and. Let me tell you about some research that kind of nails that home. Building mathematics knowledge does not require sacrificing play. Indeed, activities that I showed you are very playful. We always approach mathematics in a playful way. Play is creative thinking. Playing with objects is fun. And kids naturally use mathematics in their play. Herb Ginsberg did a study. Average percentage of minutes in which mathematics activity occurred. When I first read about this study, I thought, I don't know, kids doing math when they're just free playing? Maybe, I don't know, 10%, maybe more. It depends on what you count. No. Nearly half, 42% of every minute that Herb and his research colleagues examined, they took 1 minute at a time, they'd look, is there any mathematics? Had something mathematical. Kids were enumerating, they were comparing quantities, they were talking about how when you roll out some plasticine, that the snake looked longer, but was it heavier? I don't think so, I'm not sure. I think it's more clay. No, it's not, because you just rolled. Great discussions, right? They did shapes, they did comparison, they did patterning on their own. And there was no difference between the type of play the amount of play, except in one category, shapes was a little bit different, between kids who came from a low resource community and kids who came from very high resource communities in New York City, where they did the study of these two sites. No. And then you might think, if you've been following some of the equity issues I've been raising, well, wait a minute, if they play the same, how come there's differences? Because not all those kids always get an opportunity to learn the language of mathematics. So whether it's subitizing, counting, patterning, learning shapes, and the kind of thing, intentional activities, intentional use of language, like I told you about in Hanula's research and the like, very, very important, because we need to make equal the opportunities kids have to learn the mathematics. Makes a huge difference for kids who are dual language learners or English learners, as well as for kids from different groups. More research on play. This was actually a Vanderbilt study, very interesting. They looked across many, many studies, and they found that curricular focus leads to stronger emphasis in subject matter. Yeah, you don't have to parse that too deeply. All it means is if you teach math, they learn a little more math. If you teach literacy, they learn a little more literacy. Okay, fine. That wasn't the point of the study. Here comes. Children who learned a little math or who learned a little literacy were more likely to engage at high quality socio-dramatic play. Just that kind of play that develops language, executive function, or self-regulation skills and the like during free play. Whoa. Academics not only didn't quash free play, it benefited free play by giving kids interesting ideas that came out in their play, right? And children in classrooms focusing on both math and literacy were more engaged at the high socio-dramatic play level than neither or either one alone. It's both and. It's both and for domains, it's both and for academics done well and play. So we want kids to play, but we want them to play with ideas, right? Regular play with blocks and puzzles and socio-dramatic play with self-regulation is good. And enhancement of math in that play by setting up interesting activities, by introducing materials that you know will help develop these math skills. And intentional planned math along learning trajectories, short but focused, small group and whole group activities and computer activities, and then finally play with mathematics. I think I have time to tell you one more story about that girl who started the first video you saw, Abby, that was Julie interviewing her. She's her daughter, so she's had plenty of opportunities, more than sometimes our kids ever wanted. And when she was 3, we brought home 5 plastic foam trains. Early version of our learning trajectories were in something called Early Childhood Express, and they had this kind of train theme, right? So at the end of the conference, they had all these trains left over. We took 5 home. Abby liked to play with them. And one day, Julie walked by and saw Abby with 3 trains. And she said, "Oh, you playing with your engines?" And Abby said, "Yep." And she said, "Where are the other ones?" And Abby said, "Oh, and she holds them up and points to them and says, "I have 1, 2, 3, so I'm missing 4 and 5. I'm missing those 2. No, I'm missing 1 and 3 and 5. No, I have 1 and 3 and 5. I mean, I'm missing 2 and 4. 2 and 4. So I'm still missing 2. What was she doing? She was playing with ideas. Abby was playing with the notion that if you had 3 objects and you knew 2 were missing, you could number those 3, 1, 2, 3, or 1, 3 and 5 and be missing 2 and 4. You could even number 3, 4, 5 and say I'm missing 1 and 2. It didn't matter because the logic is the same, right? Play with mathematical ideas emerges when kids have a lot of opportunities to think mathematically. So I end with this. I'd like to remind you that here's our website. It's called Learning and Teaching with Learning Trajectories. So the initials are LTLT, or we call it LT squared, right? It's one of those math jokes devoid of humor, but we like it anyway. And it's available free to anyone at learningtrajectories.org. And it has, when you go in and you pick Subitizing, you can see all the levels of Subitizing. This is just a static shot, of course, and a video of a kid who, the definition is at top, and then the child there, one or more videos. This is actually one of 2 videos that exemplify what that level of thinking looks like. And then you can see levels before or levels after. And then if you click on activities, it simply scrolls down, right? And shows you, here are some example activities. And once you click on one of those activities, actually, boy, you click on this one, there's software right there that you can sign your kids up to play with. And it'll keep track and move them to the right level along the learning trajectory, right? Here you see a set of dots there in that display. And if you click on the numeral corresponding to it, numerals come later. First, we just match sets to sets, stuff like that. But this is a certain level of it. Then you get closer to the plan, closer and closer and closer, which motivates kids to keep going. Fantastic 5, if you click on that, you actually go to a separate page where there's videos of Fantastic 5 and PDFs in English or Spanish that you can download to know what the activity's about. It's not just this picture, right? You go to that activity and learn more about that activity. Here, it's subitization because what we do is we hide like maybe 2, 3, and 4, and then we say which one's 4, and they get to flip it real quick like that and say whether it's 4 or not, you know. So that those are the kind of examples. So I'm done. I appreciate your time. We missed out on Julie's story, so that does give us a little bit of extra time at the end. If there's anybody that has any questions or the like, I would love to entertain them. So I think you can type them into the box if you have questions, concerns, and concerns or even ideas on what you've done with learning trajectories or the like would be welcome. No. Okay.
Okay, Doug, here's one question that we've got. What suggestions do you have for teachers to promote Subitizing during remote teaching?
Oh, that's such a good idea. That's such a great question. And I'm going to answer it, I promise you. But let me go backwards a little bit. I should have said that when I was trying to tell you very quickly about the Learning and Teaching with Learning Trajectories website. Go to Resources, the Resources tab, and you will find lots of virtual teaching suggestions, some for parents, some for caregivers and teachers and the like. And so there are some guidelines where to start, how to do it virtually and stuff like that. And I forgot to say that. So thank you for the question. It slapped me upside the head that I forgot that one. So back to your question. What do you do with Subitizing? Yeah, in virtual teaching, it would be fun to do that kind of Subitize game. But let me tell you a little variation that we would do on it, right? I showed you a picture that showed some objects on a table and then a plate over them, right? And the teacher was going to reveal that for 1 or 2 seconds and put the top back on and then ask the kids to think, pair, share how many. If you're virtually teaching, An alternative that teachers have found extremely effective and easier to manage and perfect for virtual teaching is to simply get stampers and put dots on white paper plates in various arrangements, like we talked about before, and numbers that fit the kids that you're working with, right? And then just hold that up and then put it down and say, kids, if they're looking at the class of kids, right, don't tell me yet. I'm going to say ready, set, go. And when I say go, you hold up the number of fingers that shows how many dots you saw. So you can play these subitizing games very well, and then hopefully parents will pick up on these kind of things and suggestions that you send home. And remember, parent activities are also in learningtrajectories.org. So look for those as well. Because it's a PDF, you can share it with parents. Parents can sign up to learningtrajectories.org. It's free to everyone. All you do is put in your email and you make up a password and you're in. So anybody can go there, or you can just share the PDF of an activity you like by emailing it to parents. Hope that answered the question, but more questions or follow-up questions are great.
Okay, here's another one. When is developmentally appropriate to encourage children to trace numbers?
Oh, good one. So I'm assuming you meant trace numerals. In other words, the written number, like the 5 I showed when I said that's not subitizing, but it's an important language arts skill. The research on that is a little open, but I do know 2 things. 4-year-olds, if they have the fine motor control and the motivation's pretty important, but kind of not too hard to develop if it's not present there. 4 and 5-year-olds are fine to start doing that and to trace them. Art Baruti's research shows one more thing, if I can hopefully not bore you with the details, and that is you really need a motor plan for the numbers. So kids need to know it's not just a visual image they need. They need a motor plan for writing, so they think, okay, for the 6, I come down and I head towards, some teachers say towards the windows, if they're in a classroom where that's a stable kind of thing, down and then loop around and touch again. I can send people Art's motor plans if you're interested, but those kind of things are really important. So make it not so much about just the visual image, but also include these kind of actions your hands take to make them Art finds, especially for kids who have special needs, incidentally, but for all kids, it's helpful. More questions? I'm sorry they didn't come up on my interaction window, but we have a couple more minutes.
Perfect. And we do have a couple more questions. Lourdes was wondering, where can I find these cards to print?
So I mentioned that there's a PDF giving instructions for the activities, right? In the activities themselves on learningtrajectories.org, but so are the materials. There's PDFs right there. You can, again, send them to parents or have parents sign on, whichever is easiest for you. And parents could print them out if they have a printer. I know there's equity problems there as well that we're all facing. So the materials that you need, either there's a list of common materials right there listed for you, exactly what you need for any activity, hundreds and hundreds of activities at different developmental levels for different topics, or there's a PDF that you can print out and use. More.
You just want more and more. We have time for one more question.
Go ahead.
And that is going to be from Crystal. Ideas for the best/appropriate way to assess cardinality.
Oh, good one. Good one. And I know I'm going to go over time, so I'll just, the best way to assess cardinality is really to have kids count an amount and then just cover it and say, so how many were there? Because then they can't subitize it and answer, or they're prevented from just recounting if that's their habit. So just do that. And that's cardinality. Remember, that's cardinality in the counting process. Of course, when kids subitize and just know that's 2, that's how manyness too, but it's not the cardinal rule of counting, which I assume is what you meant. Thank you, everybody. I think I'm going just a teeny bit over time. I really appreciate you. See us on the web. Send me email. You can also send us email by going to the web and posting there. I love it. I love early childhood math. I love people who support early childhood math and all of STEM and literacy and social emotional development. Thanks so much for having me.